Namaste to all of you. Present we are doing the binomial theorem chapter. In this binomial theorem, already basic concepts is completed. Now today I will explain numerically greatest term. How you can identify numerically greatest term in the binomial expansion. You can follow the date. Today date is okay. And one more thing, ma'am. Here I want to share with you my syllabus. Only the pending chapters are present. Only algebra lagging is there. Algebra and in calculus part, maybe I hope areas and differential equations. So total means in algebra, what are the pending is first of all quadratic expressions, theory of equations, that is over. Now binomial theorem, one chapter, permutation combinations, probability, matrices and determinants. After that, areas, differential equations. Now if you take it, this is already within 7 days it will over. This is total 10 days. This is total 10 days. 10 days means two classes. If I take two classes, I can wind up like that. Now if I count matrix determinants also 10 days, areas and these two, it will be 15 days. So total, if you observe now, means today August ending is there. So September and October 15th I am planning like that. So from my side mathematics I will finish my syllabus up to October 15th. From my side teachings I will finish. Then from your side, that practice point of view, compulsory you have to do. So and one more thing I want to say for your batch, don't expect like that your exam will be in the month of March like that. So maximum as per schedule means your exam will be maybe in the January and or February starting, it will be like that for you. So don't think any otherwise. That means maybe few students they may thought your exam will be postponed like that. No, your exam as per schedule only it will go on. So better thing is keep on doing, okay, and practice mathematics. And a number of times I told you already, in mathematics how you can proceed. First of all, by listening my classroom teaching, immediately you have to do Deepthi book. After Deepthi book, then you can go through level 1, level 2, Narayana material you can do. After level 1, level 2, then you can go to Singage, higher level bits. So this is the method. Number of times I am telling to you. So you can follow like this only. Okay. Now we will enter into the today class. Today class we will discuss about the NGT, numerically greatest term. Numerically greatest term. So if they will give this is also important, but why these conditions and how that formula, leave it. Just I am telling you how to find numerically greatest term. Means only this is the bit till now they didn't ask, but numerically greatest term you can listen. One formula is there. That formula derivation I will not give. Okay, if you want you can ask me personally, then I will send you. So here if the expansion is like this, 1 plus x whole power n, here n is the positive integral index, where n is the positive integral index, and mod x value less than 1 means minus 1 less than x less than 1. Then to find numerically greatest term, to find NGT, to find numerically greatest term, what we have to do? First we have to calculate P is equals to n plus 1 into mod x by mod x plus 1. First this quantity we have to calculate, n plus 1 into mod x by mod x plus 1. After calculating this value, there are again two cases will be there. So after calculation of this value, there are again two cases. Maybe P is integral value, P is integer value, one value. Otherwise, P is not integer. These are the two cases will be there. Now what we have to do? For example, if P is integer, if P is integer value, then directly here TP comma TP plus 1 are two numerically greatest terms exist. Two numerically greatest term exist. This is the first point. For example, directly if you calculate this value n plus 1 into mod x by mod x plus 1, if you will get P value as integral value, then automatically TP comma TP plus 1 are two numerically greatest terms will be there. For example, this is the first case. Second case, if P is not integer, if P is not integer value, now in this case, what are the numerically greatest terms, ma'am? T step P plus 1 is numerically greatest term. Only one term only exists, ma'am. That too, the numerically greatest term is T step of P plus 1. That means, for example here, ma'am, if you calculate P value, if P is equals to 5, one integral value, then automatically T5 comma T6 are NGT, numerically greatest terms. Or next case, for example, if you calculate P value you will get some 4.6 like that. Then within this case, T step P plus 1 means T4 plus 1 means T5 is the numerically greatest term. So this is the overall concept. Now basing on this concept, one or two examples we will do, then you can understand easily. So the formula is to find NGT. This is the formula. N plus 1 into mod x by mod x plus 1. Basing on this P value, we will identify what is the numerically greatest term. Okay. Now, one or two examples we can do. Then only you can understand easily. Okay, now listen. One example I will tell you. Sorry. Here they give, listen. Find the numerically greatest term. Numerically greatest term or numerically greatest terms in the expansion of 2 plus 3x whole power 10 when x is equals to 11 by 8. Okay, ma'am. So this is the one example they given. Find the numerically greatest term or terms in the expansion of 2 plus 3x whole power 10 when x is equal to 11 by 8. Listen first of all. So here to find numerically greatest term, the expansion should be 1 plus x whole power n. This form should be there. So, but here 2 they given, immediately you can common the 2 value. Then if you common, listen, 2 plus 3x whole power 10. If you common 2, automatically power 10 also will common. 1 plus 3x by 2 whole power 10. This is the value you will get it. Now, for NGT, for numerically greatest term, what we have to calculate? P value already given. P value you can calculate. What is that P value? N plus 1 into mod x by mod x plus 1. Of course, here you can take capital X. Already they given small x. Now n plus 1. What is n value here? 10 is there. So 10 plus 1 into mod x. Mod x means in place of x, 3x by 2 is there. So 3x by 2 by modulus 3x by 2 plus 1 is the value. Then how you can simplify this value? Already x value they given 11 by 8. You can substitute x value 11 by 8. Therefore 11 into 10 plus 1 11 into 3 by 2 anyway positive only 3 by 2 into 11 by 8 is the value by denominator value 3 by 2 into 11 by 8 plus 1 is the value. Now simplify this whole value. If I simplify the whole value, 16 you will get it. So 11 into 3 into 11 by 16. This is the numerator value. Denominator 16 also there. So 16 will goes to numerator by here it is the value 33 plus 16 you will get 16 get cancelled. Then if you simplify 11 into 3 into 11 by this is the value you will get the value 49 is the value you will get it. Then simplify after this one. Is there any cancellations? Then 11 11s are 121 you will get it into 3. Okay. Then if you observe here like this, so 363 by 49 you will get. So 363 you can divide with 49. What is the value here you will get? For example, if you observe here, maybe 5 times, 6 times, if you 7 times if you observe, into 7 if you take it now. So 6 times you have to proceed. 7 times you can do it now. Yeah, 7 times you can do it. 7 times if you do it, you will get the value like this, means 7 point something you will get it, 7 point something. So 7 point something means, therefore numerically greatest term is t step of p plus 1 which is equal to t7 plus 1 which is equals to t8. So 8th term is the numerically greatest term in that expansion. So here if you observe, only the calculation of the first value, calculation of the p value is important. After calculating that value, therefore NGT, what is NGT value? Therefore NGT equals to T8 is the value. Now conclusion, so T7 plus 1 which is equals to what you will get here, otherwise you can take this one only. Then 10C7 into 2 power 10 minus 7 means 3, 3x whole power 7, replace x is equals to 11 by 8 is the value. That's it. So in every example compulsory they will give in this manner, x value also they will give, like this expansion they will give, but to calculate numerically greatest term, the expansion should be in the form 1 plus x whole power n should be there. So whatever the value here it is there, you can common that value, then you will get 1 plus x whole power n form. Then for this, the first step is you have to calculate p value. What is that p value? The p value is given by n plus 1 into mod x by mod x plus 1. Then after calculating this value, you will get p value. Depending upon p value, if it is integral value, there exists two numerically greatest terms. If it is not integral value, then t step p plus 1 is the numerically greatest term. Only one term only exists. So this is the working method to calculate the numerically greatest term. I hope that this is clear for you. Now, now one more example I will explain to you. Okay. here one more thing is find the next example. One more example I will give. Find the numerically greatest term or terms in the expansion of 4 plus 3x whole power 15 when x equal to 7 by 2. Okay, ma? So this is the one more example. So in this example, same thing here also. First of all, observe what is expansion. The given expansion is 4 plus 3x whole power 15. So immediately to find numerically greatest term, the expansion should be in the form of 1 plus x whole power n. So immediately you can common 4 value. Here you will get 4 power 15, 1 plus 3x by 4 whole power 15 is the value. Now what is the next step? We have to calculate p value. Therefore p is equals to what is the formula? N plus 1 into mod x by mod x plus 1. This is the p value. Our aim is to calculate this value. Then n plus 1 into mod x by mod x plus 1. Of course, n value they given as 15 is the value here, 15. So 15 plus 1 into, here you can use mod x, capital X, already here x is there. So modulus 3x by 4 by modulus 3x by 4 plus 1 is the value. Now 16 into, what is the value? 3 by 4 into x value, 7 by 2 by 3 by 4 into 7 by 2 plus 1 is the value. Now simplify these values. If I simplify these values, 4 here 4 2s are 8, 8 2 times get cancelled. Then what about this value will be 42 by, here it is the value 21 plus 8 and 8 will go to numerator. Then here it is the value. If you simplify 29, here you will get this is the value you will get it. Now you can calculate. What about this value will be? Here it is, 336 you are getting, and you have to dividing with 29. Got it now? Here if you observe 7 3s are 21, 4 2s are 8, 29. Then numerator value here 42 into 8 you will get it, So total is the value. So 336 you can divide with 29. Then what about this value? Compulsory, not integral value. Maybe if you observe here, so 11 point something you will get it. So 11 point something means, therefore what is the numerically greatest term is t step of p plus 1 means t 11 plus 1 which is equals to t 12. So 12th term is the numerically greatest term, you will get it. Got it now? Then automatically after getting the 12th term, what we have to do? You can simplify the value. Simplify the value means calculate t12 value. So t12 is equals to, t12 is equal to what is the value will be? 15c 11, since this value you have read 11 tr plus 1 form, into 4 power 15 minus 11 4, next 3x whole power 11. Replace x is equal to 7 by 2. So 15c 11 into 4 power 4 into 3 power 11 into x power 11 means 7 power 11 by 2 power 11. You may simplify, this value get cancelled, you will get the answer. Okay. So this is the method to identify numerically greatest term in the given binomial expansion. Okay, I hope that this is clear. Now all present we are doing, this is the basic level. Later finishing this basic level now, then we will go to high level. Present basic. After finishing this basic level, then we will go to high high level like that. Okay, present basic only. Now exclusively we will discuss about the binomial coefficients. Exclusively now we will discuss about the binomial coefficients. Binomial coefficients means, for example, a plus b whole power n. In this expansion, a plus b whole power n, what is the binomial coefficients means? nc naught comma nc1 comma nc2. And a few students they will write nc2 like this. This is not correct representation. nc2 like this only we have to represent. Keep in your mind. Next nc3, nc4 up to so on ncn are called binomial coefficients. These are named as binomial coefficients. Okay, and simply these are denoted by here. These are denoted by simply c0 comma c1 comma c2 comma c3 so on cn. Means instead of every time we are writing nc0 nc1 nc2, simply you can mention c0 c1 c2 c3 so on like that. This is also correct notation only, nothing is wrong in it. Next, and here already related to these binomial coefficients, formula already be given. What is NCR formula? N factorial by n minus r factorial into r factorial. This is the first formula we given. And factorial n or n factorial. What is this value? 1 into 2 into 3 into up to so on n. This is also we given. And here 1 factorial value equals to 1. 0 factorial value is equal to 1. All these points I given already. Next one here after this one more formula I given. NCR is equals to n minus r. This is also important formula. NCR equal to NCn minus r means, for example, 8C2 value is equal to 8C6 equal, and 8C3 value is equals to 8C5. If you add these two, you will get 8. If you add these two, you will get 8. After this one more point also we given. What is the point we given? NCR by NCR minus 1 is equals to formula what we given? N minus r plus 1 by r. This is also point we given. After this one here one more values we given. NC naught is equals to NC n is equals to 1 is the value, and next NC 1 is equals to NC n minus 1 is equals to n. These values also we given. Okay, all these are the concepts we completed already. So these are the binomial coefficients, and till now all these concepts we given already. Now in detail we discuss about the binomial coefficients. Well, entering into in this, listen. One simple notation I will give. For example, my aim is to find 8C2. What is 8C2 value? 8 factorial by 8 minus 2 factorial into 2 factorial. So 8 minus 2 factorial means 6 factorial. So total this value is given by 8 factorial by 6 factorial 2 factorial. Then this 8 factorial means 1 into 2 into 3 into up to so on 8. 6 factorial means 1 into 2 into up to so on 6. Then what is the value remaining here? 8 into 7 by 2 factorial means 1 into 2. Got it now? This only you will get it now. So simply 8C2 means starting with the 8, take 2 factors by 2 factorial. Similarly, if you calculate the value 8C3, if you calculate 8C3, what is 8C3 value? 8 into 7 into 6 by 3 factorial means 1 into 2 into 3. It is the easy way to remember this one. So 8C3 means starting with 8, take 3 factors by reducing 1 in numerator by 3 factorial. For example, if I give 15C4, what is this value? 15C4 means simple logic. Starting with the 15, reduce 1 by 1, take 4 factors in numerator, means 15 into 14 into 13 into 12 by 4 factorial, means 1 into 2 into 3 into 4. So remember this method, easiest method. So if I give NC2, what is this meaning? NC2 means NC2 means starting with the n, take 2 factors by reducing 1 by 2 factorial, means this is the value. Similarly, if I will give NC3, what is this meaning? If you simplify, what is the simplification method? In generally, n factorial by n minus 3 factorial, 3 factorial. This only we will do now. NCR, n factorial by n minus r factorial, r factorial. Now numerator value n factorial is there now. How I can write? N into n minus 1 into n minus 2 into n minus 3 factorial. How I can write? Simple logic. If 8 factorial is there, how I can add 8 factorial value? 8 into 8 minus 1 factorial. Can I write like this now? Means 8 into 7 factorial. How I can add this value? 8 into 8 minus 1 into 8 minus 2 factorial, means 8 into 7 into 6 factorial. Can I write like this now? So basing on this, I can mention like this also. By denominator value, n minus 3 factorial is there, and 3 factorial means 1 into 2 into 3. So these both get cancelled. Then you will get n into n minus 1 into n minus 2 by 1 into 2 into 3. This is NC3. Got it now? So why I am giving these values means this we can use. This we can use. So simply if they will give NC4, tell me what is NC4 value? Starting with n, reduce 1 take 4 factors in numerator, means n into n minus 1 into n minus 2 into n minus 3. 1, 2, 3, 4. 4 factors. By denominator value, 4 factorial. Like this. So means n into n minus 1 into n minus 2 into n minus 3 by 1 into 2 into 3 into 4. This is NC4. So by generalizing this value, for example NCR, if they will give NCR, how I can add NCR value? Tell me. If they will give NCR, what is NCR mean? NCR, if you simplify, directly you will get n into n minus 1 into up to so on n minus r minus 1 by r factorial. Got it now? By starting with n, reduce 1, take r factors. For example, NC2, here n into n minus 1. NC3, up to 2 you can take n into n minus 1, n minus 2. Similar manner like this. NCR, NCR means starting with n, take r factors in numerator, by denominator r factorial. So n into n minus 1 into n minus 1 up to so on n minus r minus 1 by r factorial. So till here numerator r factors starting with n, reduce 1 by r factorial. For example NC5, what is the NC5 value? Tell me directly. N into n minus 1 into n minus 2 into n minus 3 into n minus 4 by denominator 5 factorial. 5 factorial means 5 into 4 into 3 into 2 into 1 is the value. So this is a calculation point of view given. It is easy. Okay. So keep this point also, important point. NCR value. How you can get easily NCR value. Listen, after this one, if you observe 1 plus x whole power n expansion, if you observe 1 plus x whole power n expansion, if you observe, what is 1 plus x whole power n expansion? Tell me. 1 plus x whole power n is equals to c naught plus c naught means n c naught plus c1 into x plus c2 into x square plus c3 into x cube plus up to so on cn into x power n. Got it now? Okay. Like in the binomial theorem only, directly binomial theorem. Here 1 is there, so due to that reason, 1 highest power you will get. Gradually 1 highest power reduced. Anyway, 1 highest power means 1 only. And in the beginning term, x power 0 it will start. Gradually x power value increases. In the last term it will changes to x power n. And how many terms are there? N plus 1 terms are there. Now listen, in this expansion, replace x by 1. In whole this expansion, if I replace x by 1, what I can get me? Tell me. 1 plus 1 means 2 power n I will get it now. Directly this is the value of 2 power n equal to this side also. Wherever x is there, x value you can replace 1 only. Then what you will get? Tell me. C naught plus C1 plus C2 plus C3 C4 up to so on plus Cn is the value. So sum of the binomial coefficients is equals to 2 power n. This is the first basic formula. C naught plus C1 plus C2 plus C3 plus up to so on plus Cn is equals to 2 power n. This is the first one important formula. Okay, sum of the binomial coefficients is equals to 2 power n. First formula related to binomial coefficients. Okay, next one. After this one, listen. If you observe the expansion, so this is the binomial expansion, binomial theorem. 1 plus x whole power n is equals to, we know that one, c naught plus c1 into x plus c2 into x square plus up to so on plus cn into x power n. For example, if x is equal to minus 1, before I replace x equal to 1, but now I can replace x equal to minus 1. If x equal to minus 1, what I can get? Tell me here. 1 minus 1, 0. Tell me what about this value? C naught. This value minus C1 plus C2 minus C3 plus C4 minus C5. Like this you will get it. Of course, if n is odd, here minus you will get. If n is even, plus you will get. So means let it be like that. Then here in this expansion, all these minus terms, if you bring this side, then what you will get? Tell me, what are the remaining terms here? C naught plus C2 plus C4 plus and so on is equal to C naught plus C2 plus C4 plus on equal to. Bring this minus C1 this side, minus C3 this side, minus C5 this side. Then what I can get? Tell me. C1 plus C3 plus C5 plus so on. This is also one more important point. Means sum of the even binomial coefficients is equal to sum of the odd binomial coefficients. Means here the point is C0 plus C2 plus C4 plus so on is equals to C1 plus C3 plus C5 plus so on is the value. So this is also one more important point. So till now we derive first one. What is the first one value? C0 plus C1 plus C2 plus C3 plus and so on plus Cn is equals to 2 power n. This is already we completed. And here the second property what we got here it is C0 plus C2 plus C4 plus so on is equals to C1 plus C3 plus C5 plus so on. This is the next property. Now listen, one more property we will discuss after this one. So this is the expansion, we know it. 1 plus x whole power n is equal to, this is the expansion. Now in this expansion, if x is equal to 1, if x equal to 1, what I can get, tell me? 2 power n is equal to C naught plus x plus 1 if you keep, C1 plus C2 plus C3 plus so on plus Cn is the value, that is okay. You can replace if x is equal to minus 1. If x is equal to minus 1, here what you will get? 1 minus 1, 0. So 0 is equal to, now replace x equal to minus 1. C naught minus C1 plus C2 minus C3 plus 1 plus, here you may get minus 1 whole power n into Cn is the value. Now listen, let this is the equation number 1, let this is equation number 2. Add these two values. If I add these two quantities, what I can get, tell me? 2 power n plus 0 means 2 power n I can get, equal to C naught plus C naught, 2 times of C naught I can get. These two get cancelled since I am adding na plus quantity minus quantity, both will vanish. C2 plus C2, 2C2, already here I written 2, so plus C2. Next what is value, guess it, mom? C4 plus C6 plus so on, like this I can get it. Now if you simplify this value, then bring this two value this side, then what is the remaining value, mom? Here it is C0 plus C2 plus C4 plus C6 plus so on is equal to, what is the value? If you bring multiplication is there, dividing, you will get the value 2 power n minus 1. So this is also one more important property. Now here listen, one more point. So this is the third point. So here I am writing today derivation, third derivation. What is the derivation I got here? C0 plus C2 plus C4 and plus so on is equal to 2 power n minus 1. Now listen here. But in the second result, if you observe, in the second result, if you observe, in the second result, what I given? C0 plus C2 plus C4 plus so on is equals to C1 plus C3 plus C5. But here C0 plus C2 plus C4 value, nothing but 2. So automatically from this, but even this quantity C0 plus C2 plus C4 value is nothing but C1 plus C3 plus C5 plus so on. Of course, this value is also equals to 2 power n minus 1. This is the one more important point. So binomial coefficients, they will satisfy. The first condition is sum of the binomial coefficients is equals to 2 power n. Keep in your mind. And this is the property. Later in permutations, combinations also we will use the same property. Next property is C0 plus C2 plus C4 plus 1 is equals to C1 plus C3 plus C5 plus 1. That is the next one more property. And the next property C0 plus C2 plus C4 plus 1 is equals to 2 power n minus 1. But at the same time C0 plus C2 plus C4 plus 1 is equals to C1 plus C3 plus C5 plus 1. That is also both are equal. And the value is nothing but 2 power n minus 1. I hope that this is clear for you. Next property. Okay. Listen, after this one property is there. This is very important one. This one also, like a theorem, you can remember this one. If if CR denotes NCR, CR denotes NCR, then here it is the property. A into C naught plus A plus D into C1 plus A plus 2D into C2 plus 1 plus last value A plus ND into Cn is equals to value 2A plus ND into 2 power n minus 1. This is a very important binomial coefficients property. If CR denotes NCR, means generally C0 means NC0 this one. Sorry. If C1 means NC1. C2 means NC2. Cn means NCn, like that. Now listen. Proof of this theorem. Let the given total value. My aim is to find this is the value. Till here I have to find this is the value. So I can take S. Let S is equals to A into C0 plus A plus D into C1 plus A plus 2D into C2 plus so on plus A plus ND into Cn. This is the given value. Okay. Now if you observe here, A plus D, A plus 2D, so on. So first observation here. What is the first observation? A plus D, A plus 2D, so on. These are in which progression? Arithmetic progression. This is the first observation we have to do. Okay. So whenever these are the coefficients, A plus D, A plus 2D, these are the coefficients with the given C0, C1, C2 respectively. Now, and one more formula also we know. We know that here I am writing one formula. We know that one formula already given. NCR equal to what is the value? NC n minus R I can write it now. Already we know this is the formula. NCR equal to NC n minus R. Basing this formula, NC n value is equals to NC naught. NC 1 value equals to NC n minus 1. NC 2 is equals to NC n minus 2. Can I mention like this now? Basing on this formula, we know this. Now, here, this is the given value. My aim is to find S value. So, here I am writing, then S is equal to. From the ending, I will write. Now, from the ending, I will write. Already the given value, A plus D, A plus 2D, up to so on A plus ND, like that they given. This is our aim to calculate. So, from the ending, if you write, what you will get? Tell me. A plus ND into Cn. Guess it what? What is the next? Before this term, what it will be? A plus n minus 1 into D into Cn minus 1. This only now. Plus so on. From here I am writing last value A into C0. Understand this one? Simple This is our aim is to calculate this value. What I did? From the ending I am writing here as value. Okay. Now that implies S is equal to. How I can write this value? A plus ND into Cn. Cn value nothing but C0. According to the formula NCR equal to NCn minus R. What is this value? How I can write? A plus n minus 1 into D into Cn minus 1 means C1 I can write. According to formula NCR equal to NCn minus R. And plus so on. Last value A into the C0 value I can write Cn. That's it. So this is the first given value I have to find. I read in reverse order. I got this one. Now I will add 1 and 2. Now 1 plus 2. I will add these two values. S plus S. 2S is equal to. I am adding this value, this value. C0 is there. If you add a plus nd. What I can get ma here? 2a plus nd into c naught. Understand ma? I am adding this term and this term. You can common c naught. If you common c naught, a plus nd, this is the value, plus. Next I have to add this term and this term. Anyway c1 is there. If you common c1, a plus d plus this value, a plus a, 2a plus d, nd minus d. This minus d, sorry, this minus d plus d cancel. Again I will get nd only. 2a plus nd into c1. Like that, in the last term, what I can get? A plus a, 2a plus nd into cn. So if you observe, in every term, 2a plus nd, 2a plus nd, 2a plus nd is there, na? Common that value. So here I can get the value, 2s is equal to, if I common 2a plus nd, then I can get here c naught plus c1 plus up to so on plus cn. I can get like this. But what is the value c naught plus c1 plus up to so on cn? 2 power n, first result. So this whole value, that implies 2s is equal to 2a plus nd into what is the value? C naught plus c1 plus on cn means 2 power n is the value. My requirement is s value only. Therefore s is equal to what is value? Bring this 2 value this side. Then you will get 2a plus nd into 2 power n minus 1. So s is equal to, this is the value. But s is equal to what is the value? S is equal to a into c naught plus a plus g into c1 plus a plus 2d into c2 plus so on plus a plus n into cn is equals to 2a plus nd into 2 power n minus 1. So this is also one more important property related to binomial coefficients. That too, here the a plus d, a plus 2d, all these are in arithmetic progression. Keep in your mind. Okay, ma? In this class, till here it is enough. In the next class, we will explain few more concepts related to binomial coefficients. Okay, ma? Thank you.